Hello all. So in this class we are going to start probability for data science and machine learning. Well, probability, a very important concept, and we know that probability is based upon uncertainty, okay, of happening or not happening of an event, okay, and it's very much widely used in maths, in data science, machine learning, because we have to deal with the outcomes. Okay, so every learnable or data based mathematical model is probabilistic in nature. Obviously, na, moving ahead, we are going to train our model over the data, and then we will ask from the model to give us the prediction. Okay, so prediction can be like anything. Okay, for example, we trained our model to give us an output 0 or 1, so the output can be like 0 or 1. Okay, so what is the probability of output getting 0? What is the probability of output getting 1? This is how we do understand that there is probabilistic interpretation, because our model, machine learning models, are mathematical model. Okay, so almost all machine learning and deep learning models have the same property. भाई प्रिडिक्शन करवाना है ना आपको. ओके, तो प्रिडिक्शन के लिए कोई आउटपुट देगा, आउटकम, एंड एज आई ऑलरेडी टोल्ड 0 और 1. फॉर एग्जांपल क्लासिफिकेशन से डील कर रहे हो, सो इट मे गिव आइदर 0 और आइदर 1. ओके, तो उसकी क्या चांसेस है, 0 के क्या चांसेस है, 1 के क्या चांसेस है, प्रोबेबिलिटी. सो इफ यू डू हैव अ गुड नॉलेज ऑफ प्रोबेबिलिटी, okay, we can say that we are good in data science and machine learning. And probability is widely used in like generative AI. Okay, for example, giants, auto encoders. हाँ, तो probability लगता ही है. If you learn ahead about the deep learning and giants, means generative AI, so in that particular case probability will keep very much important. Okay, so at its core, probability is measure of the likelihood that a particular event will occur और इट विल नॉट ऑकर. अनसर्टेनिटी क्या है किसी भी चीज की होने की या नहीं होने की, रेंडमनेस क्या है उसमें. दैट इज व्हाट द प्रोबेबिलिटी इन फॉर्मल टर्म्स वी कैन से दैट दिस इज द प्रोबेबिलिटी. ओके, एंड प्रोबेबिलिटी प्लेज वाइटल रोल इन गाइडिंग लाइट टू मेक इन्फॉर्म डिसीजंस एंड द प्रेडिक्शंस. क्यों? क्योंकि ये अनसर्टेनिटी के बारे में बताता है. ओके, इट डू क्वांटिफाई अनसर्टेनिटी. So real world data is uncertain. Obviously, what can happen, what may happen, who knows? Okay, so there is uncertainty in the data. So probability allows to quantify and model this uncertainty. Probability will help us in understanding the uncertainty. Okay, it will help us in assessing the confidence level of predictions. Okay, so a model may not only predict the class of an object but also provide the probability score. For example, you got the output as 0. The probability score is 90%. Okay, 90 is the probability. You got the output as 1. If the 0 is having 90% probability, so the probability of 1 will be 10%. Okay, so it will give you the probability score also. For example, you are doing a classification problem. So in case of classification, we do use a probabilistic model. So probabilistic model will give you an output. Along with that, will also find the probability of that output. We can do that. For example, We'll be learning ahead logistic regression. Okay, so there are no probabilities used. Okay, then statistical inferencing, statistics. So drawing conclusion over the data. So already in hypothesis testing, just recently we have studied, and the data distribution. That's all also we have studied. So in case of statistics, already the portion of probability is covered. All right, we have seen the portion of probability in statistics. Okay, fine. In machine learning, understanding the distribution of data is very much important. Making inferences, making decisions is very much important. Okay, so we do take a sample of the data and we do make a conclusion over the entire population. This is what we do in case of inferential statistics, hypothesis testing. Okay, so the probability provides the foundation for statistical techniques. And if you remember, we do have a p value. So this p value is a probability value, and we compared the p value with the significance value. Okay, just I taught you recently in the previous classes. Okay, so if it is less than significance 5%, so your answer is in alpha region. If it is more than 5%, then your answer is in beta region. Beta means confidence, alpha means significance. So probability is obviously applied here also. Okay, p value. All right. Then decision making under uncertainty. See, in data science and machine learning, decision making process is uncertain. Okay, so probability will help in making a decisions. Okay, what could be an outcome? All right, so models, especially in classification, regression, we do make the prediction. They are associated with uncertainty. Okay, Bayes theorem also, that is Bayesian methods. Okay, so we do use them in hypothesis testing, new evidence collection, that I will teach you ahead. Okay, fine. This thing, evidence and what is Bayes theorem is all about, so that I will teach you. Okay, very important, Bayes theorem. And on the basis of the Bayes theorem, we are having one algorithm or model that is called as naive Bayes. Okay, so that is used for classification. Okay, text classification especially. So that I will teach you Bayes theorem ahead. Okay, so probability distributions are used to model the variability in the data. They are crucial in creating accurate and reliable models in data science. In machine learning, okay, especially those probabilistic models that leverage probability distribution, they do make the prediction. So this is how the concept of probability is used in ML and the data science. Okay, the only thing is you have to understand the distribution of the data. You have to find the uncertainty in the data, and this will help in making you the prediction. Okay, so we are having probabilistic models. We are having the models. Actually, the models in machine learning and deep learning, they are called as statistical. Statistical. Okay, we are having mathematical statistical models. Okay, so obviously probability is part of it. Okay, so if there is uncertainty in the data, if there is uncertainty in the outcome, probability will came into the picture. Okay, fine. So, probability is a cornerstone that transforms uncertainty into structured and quantifiable form. Okay, so its integration into data science and machine learning will increase the robustness, interpretability, reliability of the models, and we are going to make a powerful model based upon it. See, in data science and machine learning, you have to deal with the data only. There nothing else you are having. You will be provided with the data, and you have to completely apply maths over it. Okay, the whole concept relies in the maths only. How you interpret the data. Okay, full maths is applied. Okay, so obviously this is how the probability is important, because it deals with the uncertainty in the data. Okay, and if I do take an example for it, like sample space, that means the set of all possible outcomes for an experiment. You're doing an experiment, you're flipping a coin. Okay, so flipping a coin can give you head or tail. Okay, so the probability of getting a head is 1 by 2, and tail is also 1 by 2. 50-50% chances are there. If you are having a fair coin, so 50-50% chances are there for getting a head also and for getting a tail also. For rolling a dice, you may get these six numbers. Okay, so there is 1 by 6 chance for each and every number to come. Okay, fine. This is called a sample space. So sample space is all possible outcomes, remember. Okay, sample space means all possible outcomes, जो भी आ सकता है किसी भी इवेंट, मतलब कोई भी आपने एक्सपेरिमेंट करा, उसमें जो भी आउटपुट आ सकता है उसको सैंपल स्पेस बोलते हैं. Okay, that's what you have to remember. All the possible outcomes comes under sample space. Okay, an event E, that means any subset of the sample space. Okay, for example, sample space you are having head and tail, the subset of it is head, or the subset of it may be tail. 246 is a subset of this thing. Okay, so this is called as an event. Okay, fine. E union F, that means it is defined. E union F is defined when we are having S which represent E or F or both. So, for example, we are having two events. E is 1 2, F is 3 4. So union is 1 2 3 4. Intersection means finding the common element. So this is set theory concept. You very well know about it. इसको पता है आपको, सेट थ्योरी में यूनियन इंटरसेक्शन दोनों होता है. ओके, तो यही बता रहा है सेट थ्योरी. यूनियंस में इफ यू आर हैविंग E1 E2 E3, ठीक है, इवेंट्स हैं आपके पास, बहुत सारे इवेंट्स हैं. ओके, E1 E2 E3, if you are having multiple events, so union will be E1 union E2 union E3 union E4 and so on. That means it will consist of all the outcomes, because it's union, so all the outcomes will be considered here in the union. In case of intersection, only the common outcomes will be present, the common values will be present. Okay, that will be the intersection. Okay, fine. So intersection, here is what you are having events, so we can find the common values between them, so that is the intersection. Complement, okay, that means event consists of all the outcomes which is not present in E, that is called as a complement. Okay, so we did studied about complement also in set theory. Okay, so like, if this is a universal set, this is a universal set, and these are the elements which is denoted by A. So if this is set A, so the complement of set A to the power C, will be the rest. That means universal minus A. Okay, that means whatever be the elements which are present outside A, that will be the complement of A. Okay, fine. Okay, so we do perform this. Okay, A to the power C operation. So we are going to have the rest of the elements. So that's what in the definition it's mentioned. Okay, event which consists of all the outcomes which is not present in the event. So all the possible values which are not present in your set, that will be the complement. Okay. And we have studied that thing in simple terms also. For example, 0 का complement 1 होता है, 1's complement is 0. Okay, just interchanging the values. Okay, fine. Here are some properties of probability. Okay, so probability of any of the event, they always lies between 0 to 1. Probability value always lies between 0 to 1. This is not a new thing. You very well know about it. And probability of the sample space is equal to 1. How? If I take the probability of head and if I take the probability of tail, the answer is 1. So sample space that means all the possible outcomes. And if I take the probability of all the possible outcomes and if I'm going to add them, the answer will be 1. It's a simple thing. So the probability value always lies between 0 to 1, and the probability of sample space is equal to 1. That means in the sample space, you are considering each and every outcome and you are adding the probability of each and every outcome, it will always result to 1. Okay. Then for mutually exclusive events, probability of union of all the events is equal to probability of events and intersection of events. That is equal to 0. Something like that they have mentioned. That mutually exclusive. What do you mean by mutually exclusive? That's my question. What do you mean by mutually exclusive event? Mutually exclusive, mutually inclusive. What do you mean by this thing? Mutually exclusive events. Yes.
They have no common elements.
No, no. Okay. No common elements. Mutually exclusive. Mutually exclusive events are the events that cannot occur at the same time. Okay. So that is a general definition. Okay. Those events which do not occur at the same time, they are called as mutually exclusive events. Okay. For example, when you toss a coin, the result will be either head or tail. But it's not like that. When you toss the coin, you will get head and tail both. No, this doesn't happens. Either you will get head, either you will get tail. Okay, so such events are called as mutually exclusive events. Or there is one more term, I guess, for the mutually exclusive. They are called as disjoints. Okay, they are also called as disjoint events. Okay, fine. So if we are having the events which are mutually exclusive, that means they are all like different. Okay, so the union of all the E, probability of union of all the E is equal to sum of the probability of all the E's and intersection of all the E's. This is equal to 0. ये एक और property है. Okay, this is another property. Okay, fine. But you remember this thing, that mutually exclusive means events cannot occur or happen at the same time. Okay, so that is mutually exclusive. Fine. So this is your okay. If E and F are not mutually exclusive, that's how they have mentioned. All right, fine. Now, um, if E and F are not mutually exclusive, then PE plus PF equal to PE union F plus PE intersection F. Okay, fine. According to the property of probability. All right. Now, one more thing I want to say. This is the property of union. Okay, PE union F is equal to PE plus PF minus P intersection F. Okay, this is the property, and we have studied in set theory also this property. Okay, it's a general property. E union F. So, for example, this is E, this is F, this is E intersection F, E intersection F. Okay, so this is E, this is F. All right, so P E union F. probability of the union of the events is equal to probability of individual events minus probability of the common events, means common values in the events. This is the concept only. We do studied this thing in set theory. यही होता है, पढ़ा है अपन ने. Okay, and if you do consider E, F, and G, okay, so now it will be PE plus PF plus PG minus EF minus minus PF. Okay, where it is? Minus PEF minus PEG minus PFG plus PEFG. This is the formula. Okay, and how we get this formula? Okay, it's quite easy. You can consider this thing as one and this thing as another. That's what you can do. Okay. Or either you can consider F and G together and E is separated. It's up to you. And open up this thing with this formula, according to this formula. So at the end, you are going to get this formula only. Okay, however, we don't go in depth so much. All right. So that we will see where it has been applied, what kind of events we are having. But at least we should have some basic idea. Okay, so let me share my entire screen now, and it will be easier for us to go through this concept. Now, listen to me carefully. Okay, again, what we are studying is the core concepts of probability. Okay, fine. So, it's talking about the events. It just talked about mutually exclusive events. So, mutually exclusive, now you will not forget. That means events can't occur together. Such events are called as mutually exclusive. If you performed something, for example, you tossed a coin, you will get head or tail. Head and tail both cannot appear. This is not possible. So, such kind of event is mutually exclusive. Okay. And right now, you are just writing the formula related to it. For example, you wrote P E union F. So, you wrote PE plus PF minus PE intersection F. Okay, this is already predefined formula in set. If you are having E and F as two set. Okay, and now they have mentioned E union F union G, and the formula for this is okay, like PE plus PF plus PG. That means just write these terms, okay, independently. Then minus of EF. Now take the combination minus of P E intersection F minus P F intersection G minus P E intersection G plus E intersection F intersection G. This is the formula. Okay. Now later on they have adjusted this formula in general terms also. Okay. They have adjusted this formula in general. That means if you are having E1, E2, E3, E4, E5, E6, E7, En union. So they have written that summation of each and every event. That means probability of E1 plus probability of E2 plus probability of E3. And then minus of the combination of each and every one. E1, E2, E2, E3, E3, E4, and so on. They are going to take the combination. Later on, they are going to take the addition of the values. Okay, fine. That's what they will do. Okay, this is the formula. Conditional probability, very much important. What is this conditional probability? See, focus upon what is been taught. You're talking about probability, how you are going to relate the things. Okay, probability, sir, you told uncertainty in the data. That means anything can appear. Okay, the outcome can be anything. Okay, so how many events we are having? Are we talking about single event? Are we talking about multiple events? Just recently we took two events, E and F, and we perform union and intersection of them, and we calculated the probability also for them. And we also told them that okay, you are mutually exclusive. That means there is nothing like the same outcomes. Okay, we are having conditional probability also. For example, we are having two events, E and F, and E will occur given that F has already occurred. So conditional probability is given like PE by F. Very important, IMP. If I write PE by F, that means F has already occurred. F has already occurred. What is the chance that E will occur? What is the probability of happening of an event of E? Okay, so we are having two events, E and F. F has occurred. What is the chance that E will occur? That is calculated by conditional probability because we are looking forward for the condition. Now something happened. Now on the basis of that, another thing will happen or not. That's what you have to calculate. That is why we are talking it as conditional probability. Okay, and now, okay, just consider things in a very simple way. Okay, someone will give you an event. For example, tossing of a coin. You will say tossing of a coin is a event, and you very well know the sample space for it is head and tail. That means either head will come, either tail will come. There are two possibilities, and you toss the coin for the one time, and you got the result as head. So the probability will be 1 by 2. This is 1, and these are 2, so 1 by 2. So 50%. Probability is 50%. You got it. You got it. One event occurred, you calculated the probability. Sir, easy, sir, easy, easy. We got the probability, 50%. You roll a dice. You roll a dice. Sample space is 1, 2, 3, 4, 5, 6. And while rolling a dice, you got 1 as an output. Okay. So the probability is 1 by 6 because total are 6. You got 1. 1 by 6. Okay, it doesn't matter. You got 2 also, then also the probability will be 1 by 6. Because for each outcome, the probability is 1 by 6 only. For rolling of a dice. Someone say you are rolling 2 dice. You are rolling 2 dice. Then there are more outcomes. So sample space, you can make a combination. If I roll 2 die, I can get 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Then 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Then 3 1, 3 2, 3 4, and so on. These are the possible outcomes you will get. So total 36 outcomes you can get. If you roll 2 die, total 36 possibilities you can achieve. And for example, you got the answer as 3 4, for example. That means on dice number 1, 3 appeared, and dice number 2, 4 appeared. So what is the probability of getting 3 4? 1 by 36. What is the probability of getting 4 and 3? 1 by 36. Okay, because 4, 3 will appear one time. There's only one possibility that out of 36, there is one possibility that 4 by 4 and 3 may appear. All right, got it. So this is the thing. And now you have been told about conditional probability. Okay. So in conditional probability, it's been told that you are having two events. All right. And you are having like E and F. Okay. And it's written like P E by F. F has already occurred. What is the chance that E will occur? So E intersection F upon PF. Okay. This is the formula for conditional probability. Okay. PE by F equal to PE intersection F into divided by PF. Okay. This is the formula and very important because I'm going to apply this thing in Bayes theorem ahead. Okay. So let's understand the concept of probability, and that's what I just taught you recently. If this is a sample space, this is the event, the probability of event is 1 by 6. Why? Because you are having 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Six outcomes. This is what you got 4 2. So 4 2 is 1 out of 6. That's it. This is the probability. Okay, fine. Now, if there's a question, probability of sum 6, and on the first die, 4 should appear. So you know that there are total 36 possible outcomes if I roll two dice, and there is only one chance that 4 will appear in the die number 1 and 2 will appear in the another die, then only the sum will be in total 6. So the probability is 1 by 36. And now if it's been questioned to you, probability of first die is 4. Probability of the first dice is 4. Okay, so you may have a combination 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. So there are 6 possible combination out of total 36. So 6 by 36, 1 by 6. That's the answer. Very easy. This is how you do apply the probability. Okay, fine. So this conditional probability I already told you. We'll study more about conditional ahead. Okay. Independent events. Two events E and F are said to be independent if P E intersection F is equal to P E into PF, or P E by F is equal to PE. Why? Because if the events are independent, then it doesn't matter F will occur, what will happen to E. No, it doesn't. E and F are independent. No? So it doesn't matter to E what will happen to F. So PE by F is equal to PE. That's it. And how this thing we found? Why? Because PE by F is given as PE intersection F divided by PF. PE intersection F is PE into PF divided by PF. So PF got cancelled. Answer is PE only. So if the events are independent, it doesn't matter. F will occur, then if someone question you will E occur or not, so you will say, अरे भैया क्या मतलब है? Independent है दोनों. If both are independent, then F occur, F don't occur, who cares? All right, got it. So that's the thing. Okay, don't forget these formulas. You have to remember. All right. So the events, for example, events. These events are independent events. If if the probability of them is the multiplication of the probability of the event itself. Okay. So P E1, E2, E3, E4, and ER is equal to probability of E1 into probability of E2, probability of E3, and so on. Okay, that's what we'll say. If E and F are the two independent events, so probability of E intersection F is equal to PE into PF. Don't forget this thing. Very important formula. independent events. Okay, so this is how things got changed. Okay, so this is for independent events. But if the events are dependent, then obviously conditional probability. This is a formula for conditional probability. If the events are dependent, then conditional. F will occur. What is the chance E will occur? But if the events are independent, then who will ask F will occur, E will occur or not? Okay, but in case of dependent, obviously it's like it's conditional probability. Okay, so what is conditional probability? P A by B is equal to P A intersection B upon PB. Okay, so do one thing, do the cross multiplication. So P A by B into PB is equal to P A intersection B. That's what they have written. ये लिखा है. Okay, so for dependent events. Okay, got it. So chain rule. We can follow up the chain rule also here. Okay, and just by considering this thing only, we can do the chain rule. Okay, for dependent events. Okay, if PE intersection F is equal to PE by F into PF, then we can apply it for more than two events, and we can make a chain rule. Like for example, we are having P A1 intersection A2 intersection A3 intersection A4. So do one thing. Consider this and this overall as one, and apply the formula. So in the stage number one, step number one, you will get this thing. Okay, and then again, you can consider this as single and merge this two. So you'll get this thing. And if you got between these two intersection, you can exploit it. Okay, so that's what you are going to get the answer. Finally, it's very easy. Okay, so this is the chain rule, and what they have mentioned here is if P A1 intersection A2 intersection A3 intersection A4 is there, so the final answer is P A4 intersection of these three dot A3 intersection of these two dot A2 A2 by A1 dot probability of A1. That's what the answer is. Okay, for chain rule. Okay, now another very important concept, random variable. So what you have studied, mutually exclusive events, independent events, dependent events. Okay, mutually exclusive, independent, dependent event. Conditional probability, very important. Okay, and what is for independent and dependent? That also you have seen. Okay, so don't forget these concepts. Now, a random variable. What is a random variable? I have already told this thing in statistics. Okay, and this concept, it's like thing difficult to understand. Random variable, you know about a variable. What is a variable, sir? Something which can hold a value, different values, different interval of time, different values. And here we are calling it as a random variable, since because you're dealing with a probability, so randomness is already included. Randomness is already included if you say probability randomness. Okay, so a variable that is defined over a function. You're having a function, this variable is defined over it. Okay, this variable is defined over a function, that is called as a random variable. Now understand, Let us suppose capital X denote a random variable that is defined as sum of two fair dice rolled together. Sum of two fair dice rolled together. Okay. So if we are talking about x equal to 2, okay, if you're talking about x equal to 2, that can come, okay, that can come when you are having the outcomes as 1 and 1. So this can appear only 1 by 36. 1 will only come, okay, one time only, and total possibilities is 36. Okay, so here random variable is x. You have been told about sum of two fair dice rolled, and if they say that the sum is 2, if they say the sum is 2, so the possibility of getting sum as 2 is 1 1. Okay, total number of outcomes are 36. So 1 1 will appear one time. So 1 by 36. Now if they say 5, sum of the two dice rolled is 5. So what are the possible outcomes? 1 4 can result into 5. 2 3 can result into 5. 3 2 can result into 5. 4 1 can result into 5. So answer is 1 2 3 4. 4 by 36. So that is 1 by 9. This is the probability. Okay. Here x is a random variable, and x is defined over the sample space of the function. It is defined over the entire sample space of a function. Okay, so what is the function here? If you will ask me, sir, यहाँ function क्या था? आपने दो two fair dice को roll करा. You have rolled the two fair dice. What is the function here? So obviously I need to add na sum of the outcomes. Okay, I need to add sum of the outcomes. ये function हो सकता है. This could be a function. I need to add the sum of the outcomes. That is given to a random variable. Okay, so the random variable is defined over a function, and it can have any value. It can have any value in a sample space of a function. Okay, let's consider a few more examples. Suppose we toss a coin. Probability of coming head is p. After n flips, the answer is tail. Define a random variable. Okay, so for example, you haven't tossed a coin, n equal to 0. So probability is not, there is no probability here, not available. Now, if you tossed a coin, if you toss a coin one time, you got a head. So its probability is p. For example, you tossed a coin two times, you got a tail. Okay, you got head after a tail. You got a head after a tail. So probability of tail is 1 minus p. Probability of head is p. So 1 minus p into p. Okay. And if it happens that you got both the heads, so probability will be p into p, p square. Suppose you got both tail, so 1 minus p into 1 minus p. This is the probability. Okay. N equal to 3. Now, that means you have tossed the coin 3 times. Okay. And let us suppose you got a head after two tail. So two tail means 1 minus p, 1 minus p, and then you got head p. So for head after n minus tails, n minus 1 tails will be 1 minus p to the power n minus 1 into P. This is the general formula. Okay, now I hope you understood this problem. It's a very easy problem, not a big deal. Okay, so now if someone asks you, because in probability, a random variable is the biggest of all the concepts. Okay, fine. You have to just take care of this thing, random variable. If someone asks you, what is a random variable? You will say, okay, let me tell you what is a random variable. You say like that. Random variable. A variable is something which can achieve a value. Random means random means its probability, its randomness. So any random achievement of a value by a variable, that is a random variable. More technical. The person will ask you how. You have to be more technical. You will say, let us suppose we are having a problem statement. So that problem statement can be written in form of a function. So random variable is defined over this function. Defined over this function. Random variable denoted by x is defined over this function. And it can have any value in the entire subspace of this function. Okay, it can achieve any value from the subspace of a function. For example, you just did tossing of a coin, or if you talk about the rolling of a die, and the question was sum of the two numbers on a die is 5. So if you roll a die, two dice, so total possibilities are 36. So this is the subspace. Total is total possibilities are 36. Out of them, where we are getting the sum as 5. 1 4, 4 1, 2 3, 3 2. Four possibilities are there. So 4 by 36, your answer. Okay. So x is a random variable that is defined over a function, and it can have any value on the entire subspace. Okay, that is a random variable. And we can have discrete random variable, we can have continuous random variable, because we are having the two types of distribution in numerical. In numerical, we can have discrete distribution also, we can have a continuous distribution also. Okay, so if we are having these kinds of distribution, so correspondingly we are having discrete random variable and continuous random variable. Okay, so discrete, a random variable defined over countable, because discrete is countable no? So countable set of values, discrete random variable. Not countable, or something which can be written in class intervals, then continuous random variable. Okay, fine. All right. All right. So a random variable can be either discrete or continuous. So discrete random variable can take only countable set of distinct values. For example, number of heads obtained in multiple coin flip. This is countable. Or the number of cars passing through a tool booth over a period of time. Countable. However, continuous random variable can take only means it can take any value within an interval. Okay, for example, height of an individual, age of an individual, time taken for a process to complete, temperature measured at a specific location. All these are continuous in nature. Okay, fine. In both the cases, random variable is associated with the probability, or I already told you, probability distribution only. Okay, fine. So the probability distribution can be discrete, it can be continuous. If it is discrete, then we'll say probability mass function. If it is continuous, then we say probability density function. Remember, again, very important point, probability mass function and probability density function. Okay, so by studying the properties and behavior of random variables, we can analyze and make predictions about the outcomes of random events. Okay, so very much important. So you should be able to define what do you mean by random variable, what do you mean by a discrete random variable, what do you mean by a continuous random variable. You should be able to define them. Okay, so a random variable that is defined over discrete distribution. So that discrete distribution will come under mass function, probability mass function. If a random variable is defined over continuous distribution, so it comes under density function. Okay, so for discrete mass, for continuous density, remember this thing. One is PMF, another is PDF. Okay, and mostly we deal with this PDF. Okay, continuous distribution, because I told you normal distribution. Okay, normal distribution, because na in real world most of the data distribution is like continuous only. Okay, most of them. Okay, either you can take signal processing or image processing or this processing, that processing, the data is continuous in nature. Okay, fine. So mostly we deal with such kind of data. So we more focus upon continuous. However, discrete also will study, no worry. All right. So that is something from my side for today's lecture, and we'll explore ahead more about discrete and continuous. Okay, in the next lecture, very important. This probability, these concepts are very much important. It's hard to understand unless and until you don't get the proper guidance. Okay, fine. All right.